Good morning, students. Today the topic of discussion will be chemical reactions and equations. In this we will study how to write chemical reaction or equation and how to balance it. So let's begin. First of all, you should know that what is chemical reaction. So we have discussed in previous lecture that a shorthand representation of a chemical reaction in terms of symbols and formulae of the reactants and the products is called a chemical equation. Now it is the process by which a chemical change takes place, a change where a new substance is formed. So this is a chemical reaction where chemical change takes place. Then what is chemical equation? Just now I said that it is the shorthand representation by using symbols and formulae of the reactants and products. It has two major parts, that is reactants and products. Reactants is what? Which takes part in a chemical reaction. The substance which take part in a chemical reaction is called reactants, and the substance which are formed is called products. Reactant, the starting materials we can say, or these are the substance that changes when it is combined with another substance in a chemical reaction. And what is products? What are products? The new substances which is formed that results of the chemical reaction. So this is product. Now you see, on left hand side we will write reactant. By giving an arrow we will write the substance which are formed, which we call product, on the right hand side. Now you see about coefficient and subscript. As you can see in step number 4, it's written that if the number of atoms of any one or more of the elements on the both sides are not equal, then these are made equal by adjusting the coefficients before the symbols and formulas of the reactants and products. So coefficient is what? It is a number before the symbol or formula of a substance. Now what is subscript? So it is the number of atoms of the element found in a substance. We will see that later also. Now you see the chemical equation where we use such type of symbol, that is plus symbol, arrow symbol, and you see under bracket S. So what does this symbol mean? You see, the meaning of plus is it is used to separate one reactant or product from one another. It can be read as reacts with when used in reactant. Read as and when it is used in product. Okay. Now arrow, we read this, we use this arrow to separate the reactants from the product, or we read as yields or product produces in an equation. Now this under bracket S indicates that the substance is in the solid state. L indicates the substance present in liquid state. G in gaseous state. AQ means that the substance is dissolved in water, means small amount or some amount of water is present in the substances. Then you see this arrow, and just above that one delta symbol is there, one triangle type of symbol is there. It indicates that the heat is involved in a particular reaction. It indicates that there is heat applied or needed to make the reaction proceed. Okay. Now you see this one, this reaction. This is one example. Sodium plus water gives out sodium hydroxide plus hydrogen gas. Suppose this word equation is given and you have to write this by using its symbol and formula. So you know the symbol of sodium is Na, plus you will write first water. What is this? What is the molecular formula of water? Chemical formula, that is H2O. So we will write H2O. Then gives out, it produces sodium hydroxide, that is NaOH, and plus hydrogen gas released. So H2. Now you write the under bracket, you will write its physical state. So we know that sodium is present in solid state, water it is liquid state, sodium hydroxide solid state, and this hydrogen gas is there, so it is present in gaseous state. Now you see the reactants are sodium and water are the reactants, and sodium hydroxide and hydrogen gas are products. Okay, now you see the coefficient, which called coefficient. So you see the this 2 is the coefficient. So whenever you will you will balance a chemical equation, there you can change only coefficient or you add something in coefficient. You will not touch any subscript in any particular reaction. So whenever you need to balance a chemical equation, you will change or you will write something on the coefficient side. So you see here what is there. In reactant, sodium is present 1. This you will see later also. We will discuss this one later, that how to balance. First you see here 2H2 is we have written because we have to balance the chemical equation. Now let's proceed further. Now this one, you try this. Mg plus Cl2 gives out MgCl2. Now you see here that Mg, one atom of magnesium is present in the reactant side. In the product side also one atom is present. Cl2, two atoms of chlorine is present in the reactant side. 2 atoms of chlorine is present in the product side. So the first reaction is balanced. The second one also, C plus O2 gives out, heat is required in this chemical reaction to proceed. So heat we have given, C plus O2 gives out CO2 plus energy is released. So here also you can see that 1 atom of carbon and 2 atoms of oxygen in the reactant side. The same thing is present, the same amount or the same number of atoms is present in the product side also. So this is also balanced. Now the third reaction you see, Na plus FeCl2 gives out Fe plus NaCl. So this reaction you see here, that you can see that sodium, 1 atom of sodium is here, and in the product side 1 atom of sodium is also there. So you will not change. Now you see Fe. Fe, 1 atom of Fe is present in the reactant side also, and 1 atom of Fe, that is iron, is present in the product side. So it is also balanced. Now you move to chlorine atom. Cl2, 2 atoms of chlorine is present in the reactant side, but in the product side 1 atom of chlorine is there. So you have to add something in the coefficient side only. So here you will write 2 NaCl. Now if you write here 2 NaCl, 2 atoms of chlorine is present in the product side and 2 atoms of chlorine will be there in the reactant side. So it will be balanced. Now you see, if you write here 2, that means sodium is also gets disturbed. So 2 atoms of sodium is present over here. Now you have to write here also 2 sodium. So the balanced equation will be 2Na plus FeCl2 gives out Fe plus 2NaCl. This will be your balanced chemical equation for third equation. Now fourth equation you see, H2 plus Br2 gives out HBr. Here you see 2 atoms of hydrogen is present and 2 atoms of bromine is present in the reactant side. So in the product side also you have to make 2 atoms. So in the coefficient you write here 2, that will be balanced. So H2 plus Br2 gives out 2HBr is the balanced chemical equation. Now let's move. Let's see the law of conservation of mass. So there will be relationship of the, you can see here in page number 58, relationship of the law of conservation of mass to the balancing of chemical equations. Here you see the sum of the masses of the products is always the same as the sum of the masses of the reactants. This one we have discussed in chapter 1 also. I have told you. This one I have taught you. So here you see this law, what it states? It states that matter is neither created nor destroyed in a chemical reaction. So to obey this law, we have to balance a chemical equation. Now you see this one. Steps in balancing chemical equation. First of all, you have to check for diatomic molecules. Diatomic molecules means what? These are the molecules composed of only 2 atoms of either the same or different chemical elements. This includes H2, O2, N2, Cl2, Br2, F2 and I2. See, these are the only diatomic molecules we have in the periodic table. This only you remember. Now steps. What are the steps that is involved in a chemical equation? First of all, you have to check whether the chemical formulas of all the reactants and products are correct. Then check the total number of atoms of each element on each side of the equation. Now you have to see that a polyatomic ion appearing unchanged on both sides of the equation is counted as a single unit. Now balance the elements one at a time by using coefficients. Remember, you have to use only coefficients, not subscripts. So must not attempt to the balance to the equation by changing the subscripts in the chemical formula of a substance. You don't disturb the subscripts, you only change the coefficients. Check each atom or polyatomic ion to be sure that the equation is balanced. Now see, I'm giving you example here. If we had a container of hydrogen gas and burn this in the presence of oxygen, the two gases would react together, releasing energy to form water. So you see, H2 plus O2 gives out H2O plus energy is released. See the topic that how can a chemical equation be made more informative. So there will be some steps is there that how we can make it more informative is that above arrow you should mention that how much temperature or pressure and what catalyst required in a particular chemical equation. If you write these terms, these temperature, pressure and catalyst above the arrow, then that reaction we can make it more informative. Then the second point is physical state. It tells us about physical. If you write like you can see here in this reaction, under bracket we have written H2G, O2G. That means what? Gaseous state is present. So this will give us more information of a chemical reaction. Like hydrogen is present in a gaseous form, oxygen is present in a gaseous form, and water is present in a liquid form. So this gives us about the information regarding the physical states of the reactants and products. So we can use this one. It will make the reaction more informative. Then what I am telling you is that if you see H2 plus O2, heat is absorbed in this chemical reaction. So if you write above arrow heat, that means heat is absorbed. And if you write heat in the product side, that means heat is evolved. So in the third point you can see that C plus O2, CO2 plus heat is evolved in that reaction. Okay, so here heat is absorbed. So you have to balance this equation. So how you will balance? You see here how we will balance. Now first of all you have to count the number of atoms of each element on each side of the equation. So how many elements are here? Hydrogen and oxygen. two atoms of hydrogen and two atoms of oxygen are present in the reactant side. So we have written two hydrogen atom and two oxygen atom on the reactant side. Now you see how many atoms are there in the product side? Two atoms of hydrogen and one atom of oxygen. So here we have written two atoms of hydrogen and one atom of oxygen. Here 2 and 2 equal, here 2 and 1 not equal. Now we have to equal this. So what we will do? You see here what you will do. You see H2 plus O2. You have to assign one coefficient. So H2 plus O2 gives out H2O. So now you see two atoms of hydrogen, two atoms of oxygen. Oxygen is not balanced. So two atoms of oxygen is in the reactant side. So we will make here, we will write here, take coefficient 2. So 2 ones are 2. 2 ones are 2. So two atoms of oxygen in the product side also done. Balanced. Now hydrogen you see 2 twos are 4 atoms of hydrogen. Here also 2 twos are 4. Yeah, here we have to write 2 then. Right. So now balanced. So the whole equation is now balanced. So this is all about balancing of a chemical equation. So one more class we will need for practice of this equation, and in that only we will learn, we will read about the chemical equation, that how can we make it more informative. Okay. Okay, so read the chapter. Thank you.